All right. Hi, everybody, and welcome to today's meetup on ingesting data with Filebeat, batteries included. Nice joke there, Brian. We're happy to welcome Brian Wasserman, who's a senior consultant at Optiv, as today's speaker. Marius Iversen from Elastic, who's a senior software engineer, is joining us as well. So without further ado, I'll hand things over to you, Brian.
All right. Thank you, Faith. So as Faith mentioned, I'm talking about ingesting data with Filebeat. Just to tell you a little bit about myself, I'm a consultant at Optiv. I do work with customers supporting Elastic solutions, ingesting data in the security space. I'm also, in my past, I was a full stack developer, and I worked a lot with Python and other web technologies and scripting technologies. And then I also spent some time doing DevOps with more Python and other types of automation technologies. So with Elasticsearch, there's many ways to ingest data. And most people are aware that Logstash was the original way, or at least the original way I was aware of. And that allowed you to ingest data from files, but you can also pull data in over network ports and other interfaces. It runs on Java on the JVM, and it's not really something you'd want to deploy onto all your hosts. Usually you have dedicated servers running Logstash, and you can have a cluster of them working, but you don't want to usually put them on your servers or on all your hosts in the domain. And then Filebeat came along, which is a lightweight shipper that was written in Go. And it also has input types besides files, because even though it's called Filebeat and people know it ingests files, you can ingest from Kafka, S3, and there's other input types. And then there's also these things called modules that give you functionality out of the box. So for example, MySQL, and I just use this as a simple example. I've actually never used the MySQL module myself, just so you know. So this is how easy it is. It's as easy as looking at this example here. MySQL example, there's error and slow log files that you can point to. So in this case, you would just point it to whatever path your error logs are, and then the path of your slow log. Then to be able to visualize this in Kibana, taking advantage of the module, you use a setup command in Filebeat, and you can deploy the visualizations and dashboards. So once data starts ingesting, you have access to this dashboard, which I think I have here. Yeah. So this is just from there's a demo site Elastic has that you can poke around with some samples. So I'm just using that as a reference. So with MySQL, here's the slow query log visualization. Here's some information about just other errors and things that come from the logs. But the point is, there was no other work that I had to do. I just had to enable the module and, in this case, run it on the box where the logs lived. So Metricbeat is also another, it's another way to ingest data. Usually it's centered around metrics, given the name. And I just wanted to show an example that parallels the Filebeat example, where there are modules. And in this case, there's a Kafka module. And the Kafka module, you can just, if you just run it on the actual server where Kafka is running, you don't have to, but this is what I'm doing here. You actually just point it to the Kafka service import. And again, you would deploy and set up the visualizations and dashboards. And then once you have data flowing in, you'll have access to a dashboard like this that will provide insight into the topics and other metrics like consumer groups and the lags and other types of metrics related to Kafka. And this is actually something that's useful if you're using Kafka in your environment and you're just running all the command line tools, or without pulling a third-party product in, you can actually just turn this on with Metricbeat and be able to do this. And I use this in production. So I would say that beats are the preferred way to ingest data into Elasticsearch. There's, as I mentioned, the built-in mechanisms with modules that are very useful, and there's a long list on the Elastic website that shows you all the products and interfaces there are that already have modules created, which again shows you get the visualizations out of the box also, which is very handy. But this doesn't always solve your problems, and so there's always opportunities to write your own solution. And so here's a simple use case of say you wanted to go and get the issues for a GitHub project, and in this case it's the Elasticbeat project. You can just write a Python script using the Elasticsearch library and then pull from the API, which in this case returns JSON, write it to your Elasticsearch cluster and point it to an index and write the documents there. And technically that's all you need to do. But in practice, what happens is you hit an API. Actually, let me show you an example of the API response. So, I mean, this is the GitHub Issues API. I don't know how visible that is, but as an example where there's an array of data of documents, but that has various information about each of the issues. So what happens is there's only a certain amount of issues that come back. Let me go back to the original JSON. So in here, there's about 30 records that come back because it's paginated, because GitHub doesn't want you to pull that back thousands of entries at once. And so because of that, there's the idea of pagination where you would request a page of data or run a query, get results, and then there'll be something telling you there's more pages, or you can just iterate to the next page until you hit the end. So that would be logic that you would have to put into your Python code in this example. Then you have to worry about managing, in this case, if your server names change, or if you're using credentials of some sort, you would have to manage that in your code and hopefully keep it secure if it's credentials. Then if this is something that you're going to run on a regular basis, you may want to set it up as a cron. Then you have to deal with PID files so you don't have multiple instances running on top of each other. And this is stuff I've done. I'm sure many of you who have done before. So you can also decouple something like a script and not put any Elastic logic inside of it and just output the JSON to files on your file system, and then Filebeat can suck that data up and ingest it. But then you have to deal with log rotation and disk space and all that kind of stuff. So on a project I'm on, the client said they wanted Office 365 mailbox data ingested. This is, in context, this is a phishing mailbox. So this is a security space, and they just want to have that data coming in so they can trigger events and stuff based off of what shows up in the mailbox. And I've never done this before, so I did my research. I went to Microsoft's website for the Graph API documentation, which is very thorough, and did some prototypes in Postman to understand the interactions. But then I was hoping there'd be a way to use Filebeat and Filebeat modules to solve this problem. So I was looking through GitHub, trying to poke around and see if anything turned up that looked similar enough that I could use. And I saw there was an Office 365 module, and there's also an Azure module, but it was still a little confusing to me. So I wanted to ask in the community Slack. So I went to the community Slack in the Stack Beach channel and asked about that. So I had community members that were giving me some ideas. And then Marius Iversen chimed in, and he's an Elastic employee, a software engineer there who works with the Beats project. And he said the HTTP JSON input is actually probably the way to go, and that's actually used internally with other modules that are already built by Elastic. So I read the documentation, and I saw that it has support for a lot of functionality that I would have to roll in my own code if I was doing, Oauth and having to do pagination, as I mentioned. And there's other functionality here that I wouldn't have probably not needed in this case, but it's good to know that it's there. So in general, the docs are good for Filebeat and Elastic as a whole, but for HTTP JSON input, there wasn't a lot of examples that I was able to follow. Like I saw there was a lot of functionality, but it's just a lot to look over. And so being able to utilize the Slack and be able to interact with the community, including Elastic engineers, was very helpful. And even during this process, some PRs were written, and Marius did actually submit some changes to help accommodate my use case that seemed like something that was worth doing anyway, but it was helpful for me to be able to help the product be improved. So with all that, I still had challenges, and I made multiple trips back to Slack, and Marius and others have helped, and more PRs were written. So the end result of this example of me doing the Office 365 inbox is this. And it's not that this is the easiest thing to understand looking at it, but just to kind of walk you through it, there's Oauth 2 is the authentication mechanism. So that's something that's supported, and you get these parameters from whatever service you're using. You would have to find what's appropriate. Then here's a URL that's used to pull the data I need from the service. So that's really specific to my use case. But then another thing is, I think it's 2 pages. I'll show you the output just so you can have context. So here's an example of a payload that comes back. And in here, each entry or each response has this next link. And it's a full URL to the next page of results. So we're here in the pagination section, that this is actually building that and accessing that URL to set it so a subsequent request can take advantage of that. And then there's the messages come back in a structure of JSON, but it's not usable as JSON within Elastic unless you decode it. So I'm using a processor that is available in Filebeat and Metricbeat. It's not, or at least in Filebeat, that's allows you to transform the response into JSON document. So most people probably don't care about Office inbox messages, and I understand that, but that's pretty much what I was dealing with and what I went through. But in the end, I was very happy with the outcome, that I was able to use Filebeat and just a configuration file in the end that would be able to manage this. But I have some simpler examples for you. So as I mentioned before with GitHub, this is a URL that will get you the issues for a project. If you wanted to do that instead of in the Python example before, the equivalent thing you can do in Filebeat would be this right here. It's really just a few lines. It's the endpoint, and this data will then be pushed to the output within Elastic. And that's all you need to do. So if you do that, this is what Kibana looks like. You get all the events in here, and this is just plain text. Even though it's JSON, it's from the Elastic standpoint, it's just text in the message field. So this could be done better. And so here's the addition here would be adding the decode JSON fields, taking the message field and transforming it into JSON and setting it into a JSON key. So after that's done, there's now access to the JSON fields, and I'm able to pull them out in the discovery view within Kibana and filter on them and do whatever. But notice that all the events here are all pretty much just now. Like whenever I ran this, they're all in one place. So all the issues that come back are all being timestamped with the ingest time. And it'd be nice to be able to use the created at time of the issue to have a better way to sift through the results. So Now here I'm using the timestamp processor, and that allows you to take one of the fields and convert it to a real timestamp. And so I'm using the created at field, which I just showed. And you can give it a variety of formats, and any one that matches it'll use. So I just used that from an example and just kept it that way. And you can even include a test that will sort of, it'll be a sanity check when you start up Filebeat. It'll fail if that test isn't converted properly. So I took that as I took this timestamp field sample out of my real data just to kind of run it through the test to make sure that one of the layouts I used matched properly. So after doing this, you can see that the timestamps and the created at match, although the hours are off because one's in local time zone and one's Zulu, but it's still the same timestamp. And the events now you can see are spread through, not just all at one spot. They kind of fade back a little bit. And I did just a small enough sample so it doesn't go back that far. So now here you can see I'm keeping track of which run I do. Each time I did a run, I put like a versioning here just for demonstration purposes. So between run 2 and run 3, I pulled in the same data set. And as you can see, now I have duplicates, which is maybe okay depending on what your use case is. So going back on the Slack, Marius gave me another tip, and that was you can use the Fingerprint Processor, and you can give it a set of fields within your document, and then it'll, I guess, hash it behind the scenes, and then you can set it to another field. And in this case, if you use this metadata ID field, it'll be the ID that the document is used when it's sent to Elasticsearch. So the result of this run, this is run 4, here's the hash of that field that was generated. But the important thing about that is if you run it multiple times, the ID will be the same, which means you can prevent duplicates. So if I run it again now, remember that was version 4. Now this is run 5, so there should be a version 5, but there is no version 5. It's stated 4. And that's because even though the document wasn't duplicated, it basically was not indexed at all. So the default op type, it's called an op type in Elastic, but Filebeat's default op type used is called create, which means create the document, but if it's already there, do nothing. So another tip from Marius was you can use the script processor and you can change that op type, at least within this use case. So I'm doing the fingerprints, and then now I'm going to run script processor, and what I'm doing is setting the op type to index. And this effectively is telling it to index the document, which means it'll overwrite it or replace it. So after running it the 6th time, you'll see this thing that was version 4 before now says version 6. The document is the same, but I mean, the document was replaced, but the contents are virtually the same because the ticket didn't change in the few minutes between my runs. But the version lets you see that it actually was updated. So the next thing to deal with was pagination. And so adding in this response pagination function, or calling this using the URL params page, which is relevant to the API you use. The method I chose was to do incrementing the page number from the last page number. And so this allows it to walk through the documents. Let me go to Beats. Yeah. So there's 30 documents here, and basically the pages are, go back here, params page, last response page. If I go in the raw, there'll be, well, maybe not a good example to go there, but effectively you can walk through the documents, and then once you get to the last page, there'll be an empty array. So using that, I ran it. It walked through all the pages of all the issues. And as you can see from the timestamps, it went back in time. It's covering a year. I think I was covering a year, at least in this run. So when this was all done, this is everything in the in this GitHub issue pipeline, or whatever you want to call it. So it has the pagination, it has the message field decoding in the JSON, timestamps, conversion, setting the ID based off of a field in there, making a fingerprint, and then setting the op type to index. So I decided, since I was able to do that, why don't I have an example where I pull it from another type of issue from another service. So I decided to use Jira. This is just the Apache project Jira instance. So what I decided to do was, I figured out the API. So this URL is going to be different and have different parameters because it's a different service. The way the Jira service works is it actually has a start at offset and not an actual page number. And so instead of adding 1 each time, I'm adding 50 because each page is 50 issues per page. And that's just the nature of this interface. So that's what I'm using for my pagination logic. And then because it's an array of issues coming back, I'm splitting it. So each issue is its own document. So between wanting to have Jira and GitHub in the same Kamana view, kind of having just a single view of any kind of issues or whatever the data type is, I decided to use GitHub as my baseline or my default and normalize the data from Jira by setting the fields to map to what the GitHub issues are calling these same fields. So I'm just doing a few sets here to set fields to have a new field that would be equivalent to what the GitHub issues are using. And then another problem I had, or another challenge I had, was in Jira, the issue states, even though they're the same open and closed, as an example, the case, they use capital O for open and GitHub is all lowercase. So I just added in this script processor to lowercase the field. So that way it would be the same across both Jira and GitHub. So once that was done and I ingest the data from Jira, you can see there's now a single view where I have select fields pulled out that span both services. So as you saw, Filebeat is powerful. It's good not to always build your own solutions, and you want to be aware of what Filebeat and other tools have out of the box because they can do a lot of the work for you. The community is very supportive. It's the Elastic community, but specifically the Filebeat and the Beats community I found was very, very, very helpful during this process. It does take time and patience to work through problems like this, especially when you're new to them. But I like the fact that a single configuration file represents a data set that I'm ingesting, and I don't have to worry about documenting custom code and explaining it to someone else. You can still explain it, but then there's just point them to the Elastic documents, or it's knowledge that's transferable across projects and companies. And you also saw I can massage the data within Filebeat and not have to do it all inside of Elastic, like using ingest node or needing Logstash or something else. You can do it in Filebeat, or you can kind of do it in both. So a little bit in one end and in a little bit on the other. So I want to thank Marius Iversen for helping me work through my inbox solution and also helping me with the GitHub and the Jira scenarios. And I also want to thank the Elastic team for their hard work and support. Thank you. Any questions?
I think while we wait to see if there's any other questions open, it's nice to know a little bit about the workflow that you described, because it can be similar to when we create official integrations as well. As you mentioned in the talk, there's different takes. What I usually do would be to spin up a local Elasticsearch with Docker, because it's simply just one command. It sets itself up. We don't need to do anything fancy here, because we're only going to test Filebeat. And then, for example, install the newest Filebeat available, or build it from source, whichever you prefer. And then, as you mentioned, you can open up the Filebeat YAML, and you can start adding small parts of the configuration to slowly get to the results that you want. And I think, as you mentioned, once you're happy with it, you could even have the output be just to file or to the console, so you don't even need Elasticsearch to develop your integration at the start. So yeah, there's a lot of possibilities there as well. And we have lots of different community members that are always happy to either help out. They make a lot of PRs and bug fixes together with our teams as well. So if you haven't been around, then feel free to join us on Slack as well.
Awesome. Well, thank you, Brian, for this presentation. Thank you for highlighting the value of the Elastic community. Thank you, Marius, for joining in and for your commentary as well. I'm sure that there will be more questions that come in as this video kind of marinates on our YouTube channel. So I'll be sure to follow up with you, Brian, when those questions do come in. And just thank you again for presenting today. Bye, everybody.
All right, thank you.